Hello everyone, welcome to my channel. So this video, I hope you already have seen the first video. This is the second video, and in this video we will do the working rule for finding the complementary function, that is CF. So if the given equation is this is the general differential equation. Okay, so first step one is write the equation. Step 1 is write the equation in operator form. Okay, so if you write that down in the operator form, then it will be dn plus a1 dn minus 1 plus a2 dn minus 2 plus dot 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 plus an y is equal to z qx. So this will be the operator form. Now what is the step 2? Step 2 is write down the auxiliary equation. Okay, auxiliary equation. So the auxiliary equation is m plus a1 m n minus 1 plus a2 m n minus 2 plus dot 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 plus an is equal to 0. Okay, so we will not have the y here because it's the auxiliary equation, so we will replace the operator d by a constant by m, or you can write in the operator form you want. dn a1 dn minus 1 plus a2 dn minus 2 plus dot 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 plus an is equal to 0. Okay, so this is the step 2 and this is the step 1. Okay, now after that what you have to do, you have to just write down the find out the roots. Step so step 3rd is find out the roots of the equation. Okay, and then write it in the particular manner. So what it is, like if you have one real root, that is m1, then you will write it like that, c1e m1x, where c1 is the constant. Second, when you have two real roots, that is m1 and m2, and both are different roots, so it will be c1 e m1x plus c2 e m2x, where c1 and c2 are constants. Third, if you have three real roots and all of them are different from each other, so m1 m2 m3, then you will write it like that, c1 e m1x, let's just say its real roots first, second and third. So c1 e power m1x, c2 e power m2x plus c3 e power m3x. Similarly, you can write for n real and distinct roots. Okay, distinct root, that is m1 m2 mn. So you will write it like that, c1 e power m1x plus dot 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 plus cn e power mn x. Okay, now second, if you have two real roots but both are same. That is, if you have two real and equal roots, that is m1 is equal to m2 is equal to m, then you will write it like that: c1 plus c2 x e power mx, where c1 and c2 are constant. Similarly, if you have three real and equal roots, that is m1 is equal to m2 is equal to m3 is equal to m, then you will write c1 plus c2x plus c3 x square multiplied by e power mx. Similarly, if you have n real and equal roots, that is m1 is equal to m2 is equal to dot 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 is equal to mn is equal to m, then you will write it like that: c1 plus c2x plus dot 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 plus cn x n minus 1 multiplied by e power mx. Okay. Now third one we have, third is if you have one pair of complex roots. One pair of complex roots, that is alpha plus minus iota beta. Then you will write like that: e alpha x c1 cos beta x plus c2 sin beta x, where c1 and c2 are constants. Second, if you have two pair of equal complex roots, that is alpha plus minus iota beta and alpha plus minus iota beta, then you will write like that: e alpha x c1 plus c2x cos x plus c3 plus c4x sin x. Okay. Now the last one is if you have surd roots. If you have a one pair of surd roots, that is alpha plus minus root beta, then you will write like that: c1 or e power alpha x bracket c1 cos hyperbolic x root beta plus c2 sin hyperbolic x root beta. Second, if you have two pair of third roots, that is alpha plus minus root beta and alpha plus minus root beta, both are same, then you will write e alpha x multiplied by c1 plus c2 x multiplied by cos hyperbolic root beta plus c3 plus c4x sin hyperbolic x root beta. So these are the rules for that. Let's just do one example for that, a simple one. So first example is example 1. Example 1 is d square minus 1. Let's just write it down. Let's say d2y by dx2 minus y is equal to 0. Okay, so its solution will be, the step 1 is to write this equation in the operator form. So step 1 is to write it down in the operator form. So it will be d square y minus y is equal to 0. So it will be d square minus 1 y is equal to 0. Now step 2, write down the auxiliary equation. So the auxiliary equation will be, auxiliary equation is m square minus 1 is equal to 0, or you can use the operator also. Okay, so m will be equal to, it will be 1 and it will be plus minus 1. D is equal to plus minus 1. You can write in any of these forms. Okay. Now, then step 3 is write down in the form. So as our roots are plus 1 and minus 1, that is real and different roots. So therefore the CF will be C1 e power x plus C2 e power minus x. As we don't have any, as the function, as in this question qx is 0, so we don't have any particular integral. So therefore the required general solution for this question, general solution is y is equal to c1 ex plus c2 e minus x. That is only complementary function. We'll do example for each one in the next video. Thank you for watching this video. I hope you like this video. Please like, share and subscribe this channel. Thank you.